Tested recently spent a few days at NASA Ames Research Center in Silicon Valley to explore a few of the labs, workshops, and testing environments used in the development of space exploration technology.
One place we felt right at home was Building N220, the Technical Services Building. Housing the campus's large machine shop, it's also the home of Space Shop, a full-fledged makerspace, NASA's first, where trained staff use CNCs, 3D printers, and laser cutters to fabricate model miniatures, equipment parts, and prototypes for the other labs at Ames. We had to take a tour. So, of course, NASA Ames has their own makerspace, and it's called the Space Shop. Alex, thank you for having us here.
Yeah, sure.
You're the manager of this part of the building?
Yes, this is our humble abode, Space Shop. It's the first makerspace in the federal government. It's actually really unique in the sense that we train people on how to use our equipment, and that's typically a liability for the government. So the fact that we're doing this and we've been extremely safe over the 7 years we've been open, we've demonstrated that federal makerspaces are a safe learning environment.
That's awesome. Can we go and check out some of the tools?
Absolutely, I'd love to show you around.
Oh, yes.
Makers making.
Yeah, this is very
Space
familiar
lab.
already. I see big universal laser cutter. That's a really big bed. Wow, that's awesome.
Yeah, 3624.
That's amazing. You got some 3D printers. I see some Pruzas
Yep.
over there.
Yep, we got some additive. So we're a makerspace, right? We're unique in that this is the government, and this is a research center that does a lot of different things. It's kind of difficult to provide the tools everyone's looking for. We have a lot of different competencies out here at Ames Research Center. So we started out with the general Fab Lab, MIT kind of list of stuff. We worked with the Center for Bits and Atoms to get this place operational. And we kind of adapted to what Ames needs. We realized we need to kind of cover the generalities of a makerspace, right? Some subtractive, some additive, assembly, post-processing, and then see where projects kind of need a little bit more support on, and we go from there.
So in terms of projects, when different departments all around the campus
Yeah.
come to you, what are they looking for? Are they looking for models? Are they looking for prototyping parts?
You know, we do a little bit of all of that. We help people just get from where they are to where they want to be. And that's what I guess making is, right? Just
Yeah.
figuring out how to connect that loop.
So even things like repairing parts of the facility.
Yeah, no, definitely, right? I mean, just earlier today we were working on some parts for our wind tunnel. A lot of that is closed loop. You don't really send that outside the center. It's typically expensive to do that type of work in the government, but out here we're able to find solutions that are just as sustainable, but a lot quicker and a lot cheaper. Saves a lot of tax money. So yeah, a lot of additive in here. We're unique in that we train people on everything we do. You'll see Randall. Randall, looks like you're in a lab manual, huh?
Yeah, I'm going through the lab manual and making sure it's still current with the new up-to-date software we're running.
So you got to create documentation as well
Yes,
for the
right.
team here, interns cycling through.
We train everyone on pretty much everything that's connected to a computer. So we try to make sure that within an hour and a half, people go from any background to train. And we do that via a series of lab manuals that are pretty self-contained.
I see among the things that you have like samples of what you've made from whether you've milled it or 3D printed it.
You guys can like look up here even. I mean, we have Marscapes that we've milled out. Randall, you want to talk about Marscapes?
Yeah, so we have some Marscapes we use up here. They're just made out of standard pink insulation from like what you get at the hardware store. The one over the door is Gusev Crater. That is where the Spear rover landed. And the one on the left is Gale Crater. That is where Curiosity landed.
Yeah.
Of course, you're using like the best data sets and the coolest assets in the world, right? From NASA logos to actual topology from Mars. That's awesome.
Well, we have to incentivize people somehow, so we show them what they're comfortable with.
Wow. Is there a specific tool that the team here loves using?
I think this color printer is pretty cool. This is a powder jet printer, and it's fairly conventional as far as additive goes, but we love making meatballs on here.
And it comes full color.
Yeah. The cool thing about this is you can print out pretty much CMY. You know, we try to use each tool appropriately. Obviously, you would only really want to embed color for visualizations, right? So whenever you need to create a model for something,
Like an ISS
then that's
model?
a really appropriate tool. This is actually the highest fidelity additively manufactured model of the International Space Station. We know that because we made the model, and the visitor center wanted to create a model for this, so we were like, sure, we'll leverage what we got. But yeah, this is an area where you post-process and you take a look at what your design looks like, And it's a space for you to be able to iterate it, right, fairly quickly. We have like PCB prototyping equipment, breadboarding, SMDs, soldering. Obviously, embedded systems are really important with regards to NASA's increasingly digital mission.
In traditional machine shop, you got your bridge ports, you got
sometimes
your
you're the
sanding
CNC,
machines.
right? So, you know, cutting something in half doesn't necessarily need to involve a computer, and we want to make sure that people have a safe space to do all that work, and it's typically not at your desk.
I love it. This is such a familiar space to us,
Yeah.
having visited so many maker spaces. It's so cool to see that at Ames you guys have one. I've been running it for a couple of years.
Yeah.
Do you look always to new tools as new things come out? Are you not afraid of adopting things like, you know, the newest 3D printers? And
Well, you know, for the most part, we try to make sure that we're extending every dollar as much as we can. And sometimes that means that you're using processes that are very well defined because you know exactly what the outcome is going to be. Sometimes that means that if this is a capability people want, you consolidate it. So if SynBio wants to create something on a specific type of fluidics machine, maybe we can consolidate usage of that machine, right?
that's really rad. It seems like
Yeah.
a dream job here.
Well, everyone has their own little, task, and we just try to make sure everyone has a place to do it.
Awesome. Thank
Yeah.
you so much for giving
No,
us
of
the tour,
course,
Alex.
for sure.
Pleasure to meet you.
A pleasure to meet you as well.
The larger-than-life simulators, testing facilities, and workshops were just a few of the labs that make up the vast NASA Ames campus. In every building we drove past, scientists and engineers were at work on the numerous hard problems related to space exploration.
There's the lab of synthetic biologist Lynn Rothschild. Lynn tackles some of the hard challenges of how humans could one day live on Mars by using biology, synthesizing tiny microbes that could help build houses or new electronics for a Martian city.
So I want to show you something actually my students made last year, and that is a genuine stool made out of fungal mycelia. You can sit on it if you want. You can stand on it. It is totally human rated.
So it has real good
Yeah.
structural stability, and
That's
this is
all from
completely
fungal.
organic.
Absolutely.
So
You can see
we
it's
were actually
lightweight.
looking into, so I did a Kickstarter, we were looking into mycelium as a part of the packaging.
Uh-huh.
Yeah,
And
but
that's
it's still
another use of it as well, certainly.
yeah, because it's completely compostable.
Exactly. And
But it did smell a little bit funky. That's one of the things, because I ordered this big
Yeah,
mycelium stool and it
Yeah.
made my house smell like barn for a very long time. But this one doesn't smell as much. Maybe you used a different, maybe it's the coffee grind.
It depends a little bit what you grow it on. We've actually shown that you can grow it with a little nutrients on Mars, Regulus simulant, and lunar, which is ideal, obviously, because if we could start using it to grow things like habitats on Mars, which is something that we've also been funded to do.
So this
could be a stool
or a brick.
You could grow it into any shape you want. That's
hat?
the beauty of this.
Yeah.
Absolutely. Hat. There are a couple of companies I know who are working on high-end couture. They're making handbags out of fungal mycelia because you can end up making imitation leather. But for us, I mean, it's amazing structural material. And think about it, you get to the moon or Mars and the ground isn't level. You don't have a bunch of, trucks that have come through and excavated, and there's, craters and bumps and so on. So imagine you put up this maybe a double bag structure with some fungal mycelia in it, and it grows into shape, able to conform to the ground.
I'm starting to understand why this has the reputation of being the creative idea lab, because this is quite the breadth of project.
We also met engineers working on the challenges of landing NASA's rovers on other planets. Wendy Okolo is an aerospace engineer exploring different ways for landing those spacecrafts on the surface of other worlds.
So basically, when you think about entry vehicles, what do they typically look like? The blunt bodies, right? When you think about Orion, the Apollo capsules. But there's a different class of entry vehicles. They're called deployable entry vehicles, DEVs. They're interesting, right? Because they're stowed, and then when it's time during entry, they deploy. And they can deploy mechanically or pneumatically. But what's interesting about DEVs is they have no back shell. So it's like the one we're working on is actually like an umbrella. It looks like that. It's a variation of that one. So it like stows and then it deploys like an umbrella. So because it has no back shell, where do you put the control surface effectors and something like that? Like typically when you're controlling entry vehicles and capsules to steer during entry descent, you put RCS thrusters on the back shells of those. But there's no back shell, so where do you put it? Where? That's the kind of questions I'm trying to answer. Those are the kinds of things we're trying to solve using a deployable entry vehicle called the Lifting Nano Adept. But the technology is applicable to other classes of vehicles that are not DEVs or that are blunt body shapes as well.
Conducting scientific exploration of these new worlds won't be easy either, with extreme and sometimes unpredictable environments to grapple with. Geobiologist Darlene Lim travels to some of the harshest environments around the world to study how astronauts could fare on places like Mars and develop the protocols for future missions there.
So, all of this work is about analogs and getting to explore these really exciting places here on Earth that are like places like on Mars or Enceladus, where they've got an ocean and, all these exciting places where you get to actually be like, could realistically be at Mars right now. Like, what is that like for you? Like, is that really exciting?
It's super exciting, but the big twist is that we can't go to these places just yet. So I can't physically go to Mars yet. I can't send a robot, just yet to Enceladus. So what we do is we use our Earth as a place to start ourselves out, to reduce the risk that's associated with these incredibly high risk missions, and also to learn about our planet, because there's so much to explore, so much that's unknown to us. And every time we go out, the scientific process is on full display, and it's so much fun. And I love it as well when we build these truly interdisciplinary teams, not multidisciplinary. We have different disciplines, but you want to bring them together in one cohesive mass that, kind of then works in lockstep to solve all these incredible problems. So that's really a fun thing to be part of as well.
Perhaps it shouldn't have been surprising, but we were struck by the diversity of ideas and technical disciplines on display here. From astrobiologists to engineers, the humans furthering space exploration come from different backgrounds and tackle very different challenges. But they all share the same passion, curiosity, and drive that led them to NASA Ames.
It was an epic trip to be able to peer into some of the amazing work that takes place inside a NASA center, settled in the middle of Silicon Valley.